We have to put up with it on Christmas Eve day.
It's all good.
Are we on? Are we live? Yeah, we're live.
Technical difficulties.
Hello, everyone. Welcome to Backyard Musings, broadcasting live from Apple Valley. I'm Steve.
And I'm Scott.
Some technical difficulties here. The computer screen's going all over the place. Blustery day. What's going on today? We're going to tell you what's going on. If I can get to it. There we go. Has your wife ever told you to grow a spine? Well, scientists successfully grow human spine in the lab. There's hope for us husbands. Researchers, nobody's ever said that.
Did you
to
pick this
right?
one today for a specific reason, or because of our prior conversation?
No, well, when I saw the story, I immediately thought of Worf from Star Trek, who was crippled in a tournament. Wasn't killed, he was crippled, and so he was going to be a laughingstock. But Dr. Crusher found a way to. You guys remember this episode? Found a way to transport a spine into his body, take his spine out, and then reconnect everything, and now he's fine. He was going to be the laughingstock. They were doing therapy and stuff, and
with all the stuff that you do, how do you find time to watch all these shows?
Oh, that show was watched
years ago.
It was 15, 20 years ago. It's up here, folks.
Okay.
It's right, I'm like an elephant. It's right up here.
Okay.
You know what I'm saying?
Here we go.
That's what I'm saying. Researchers made a significant advancement in studying early human development by successfully creating a lab-grown notochord, which is a key structural component in vertebrates. This model, based on a carefully orchestrated sequence of chemical signals, mimics the human trunk's early stages, complete with the neural and bone stem cells. That's interesting. This breakthrough offers potential insights into spinal birth defects and invertebral disc conditions, marking a new era for studying human development disorders. Would you like to know more?
Scientists at the Francis Crick Institute have created human stem cells models that, for the first time, include the notochord, a tissue in the developing embryo that guides cells in forming the spine and nervous system. Fascinating.
Yeah.
The research, published December 18th in Nature, marks a significant advancement in understanding how the human body forms during early development. The notochord, a rod-shaped tissue, serves as a critical structure guide in the developing body.
It's kind of like the spinal cord, right? I mean, it's a rod-shaped, inside the spine.
Yeah. It is a defining feature of all vertebrates and plays a key role in the organizing tissues as the embryo grows. Due to its complexity, the notochord has been notably absent from previous lab-grown models of human trunk development, making this breakthrough especially important for advancing developmental biology.
Wow. Okay. In this research, the scientists first analyzed chicken embryos to understand exactly how notochord forms naturally. I guess chickens are bigger than mice, right? The mice are the go-to, but the chickens are bigger.
But
by comparing this with existing published information from mouse and monkey embryos, Fauci's Monkey Island, they established the time. Which reminds me, Festivus is out. Rand Paul's Festivus is out. We got to read that.
We got to talk about that.
They established the timing and sequence of the molecular signals needed to create notochord tissue. With this blueprint, they produced a precise sequence of chemical signals and used this to coax human stem cells into forming a notochord. Yes.
Hey, Merry Christmas, Cameron.
Merry Christmas, Scott.
The stem cells formed
Today is Christmas Eve.
It is Christmas Eve day. The stem cells formed a miniature trunk-like structure which spontaneously elongated to 1 to 5 millimeters in length. It contained developing neural tissue and bone stem cells arranged in a pattern that mirrors developmental in human embryos. What are they?
This science, man, they're pushing the edge.
I hope these people's parents are just so proud of them for what they do.
That's what I'm saying.
Yeah. This suggested that the notochord was encouraging cells to become the right type of tissue at the right place at the right time.
Nice.
Yeah. The scientists believe this work could help to study birth defects affecting the spine and spinal cord.
Nice.
It could also provide insight into conditions affecting the intervertebral discs, the shock
Those cushions.
absorbing cushions
Yeah.
between the vertebrae that develop from the notochord. These discs can cause back pain when they degenerate with age.
Yeah, fused discs, like your mobility is reduced and
Right.
a lot of pain. My
Yeah.
brother-in-law, it's like that.
I know a lot of people with back issues.
Yeah. You hurt your back, you never recover from it. But hopefully, this research, we might be able to.
Yep, this is a good thing.
And if we teleport things, maybe we could teleport a spine into a human to replace. Never mind. James Briscoe, group leader of the Developmental Dynamics Laboratory and senior author of the study, said, quote, "The notochord acts like a GPS for the developing embryo." I like how they break this down in simple terms. Helping to establish the body's main axis and guiding the formation of the spine and nervous system. Until now, it's been difficult to generate this vital tissue in the lab, limiting our ability to study human development disorders. Now that we've created a model which works, this opened doors to study developmental conditions which we've been in the dark about.
Okay.
Unquote.
Tiago Rito, a postdoctoral fellow in the Developmental Dynamics Laboratory and the first author of the study that said, quote, "Finding the exact chemical signals to produce notochord was like finding the right recipe. Previous attempts to grow the notochord in the lab may have failed because we didn't understand the required timing to add the ingredients."
Yeah, timing is important.
What's particularly exciting is that the notochord in our lab-grown structures appears to function similarly to how it would in a developing embryo. Interesting.
Yeah.
It sends out chemical signals that help organize surrounding tissue just as it would during typical developmental. Interesting.
No, here's a note from the authors. This is like a warning caveat. These structures are simplified models of the body, which contain only a small number of cell types. They develop for just a few days and cannot form embryos. So they're warning us that they're not making babies in the lab.
Right.
Their main purpose is to study aspects of human development that have been difficult or impossible to investigate directly. Trust us, we're not creating a Frankenstein monster or a human monster.
Yeah,
Right,
because you could see that comment you just made. Could you see that people that are on either side of the abortion issue saying, are these guys taking embryos from women and doing these tests? I mean, that
while they're aborting?
Well, I don't know. Yeah, I mean, every time you hear the word embryo, you need immediately. I think people
Never
immediately
thought
go to an abortion issue, either pro or against. So, anyway, hope not.
This episode really opens your eyes to we're not created by accident, right?
Absolutely not.
These complex systems in our bodies. I mean, you think of the spine, okay, the spine, but it is complex.
Right.
It's not by accident. We didn't walk out of the water as whatever embryos or whatever and
Amoebas.
amphids and grow legs and start walking and upright. That didn't happen.
We were created in God's image.
Heavenly Father created us in His image, exactly what He looks like: fingers, eyeballs, ears, nose, arms, legs,
Spinal
everything.
cord attached
Spinal
to your
cord.
brain.
Yeah, skull
running up your back.
Yes,
all your glands,
flesh and bone,
all your organs. It's just
in His image, literally.
I had somebody tell me, or we were at a convention, and the guy said, if you really think about the human body and its whole makeup, how could anybody think that we evolved? We were created, and it is so complex. It is more complex than the most complex computer.
And and our minds haven't even fully developed. They're not. The veil is over.
Yeah,
our
mine
minds.
probably never will.
No. After you pass through the veil, it will.
Well, let's see. Well,
It will.
so. I guess we're open for that.
It'll take eons to develop everything, but I mean, we just barely tapped.
Yeah, I think I may have peaked. Maybe 12.
You might have
12, 14. Yeah. After that, it was all downhill. So, anyway, till I met my wife.
She's your better half, man.
Absolutely. Yeah.
All right, folks. Thanks for joining us. We're going to have another interesting segment for you. Just stay tuned. Fascinating stuff the producers have come up with.
Take care, everyone.
Who's that mouse?
Hope you enjoy the holidays.
Okay.